evening, ladies and gentlemen, and welcome to another edition of What's Happening. I'm George Binns, and this evening's extravaganza is going to be the real story of climate change. For a little bit of background, we've done a half a dozen shows on global warming, two of them with an avowed climate activist, Kevin O'Reilly. And he usually starts his presentations off with a chart that looks like this, which is temperature versus time, starting with about 1800 through present day. And based on this, he comes to the conclusion that catastrophic climate changes will happen, and at some time in the distant future, mostly caused by burning fossil fuels. We've also done 3 shows with a climate realist, his words, Frank Bellini. And his story is one based on a chart that looks something like this, that shows the temperature over a long period of time. And he especially concentrates on the last million years, which is this range from about here through there. And what his point is the current events that we see right here are not much different than what we see in the past million years. So there's nothing different going on. This little red line you can almost make out is the climate activist comments on what's going on with the environment. And we've also done 2 shows with both Frank and Kevin at the same time. That got to be interesting. And one thing I need to point out is that it used to be the story was climate warming. Then that didn't really happen very much. And now the talk is more about climate change. So this evening, it's my turn. And in the words of the legendary Mr. Spock, the one with the pointy ears and the green skin, this does not compute. Anyone who has taken a course in thermodynamics, and I've had 5, knows that there's no such thing as renewable energy. You take your cell phone, you've used it all day, sending out, broadcasting, text messages and phone calls. At the end of the day, the battery is down. And there's no way that you can go out and grab all that broadcast information, this energy you sent out, and stuff it back into the battery. What you do is go to the wall socket, plug in your charger, and get some fresh energy into your battery. Similarly, anybody that's taken a course in heat transfer, and I've had a couple of those too, knows that CO2 is not an insulating blanket. Insulating blankets work effectively against conduction and convection. There is nothing in space for all practical purposes to conduct any heat to. And also, the gravity of the planet holds the environment pretty well attached to us, and there's no gases escaping into space carrying the heat away with it, no convection. It's all radiation. And by the way, there are no gases that act like a greenhouse. I've been in a commercial greenhouse in the middle of winter with snow on the ground, and the heat was turned off. It was chilly. And if you think about it, if glass was such a heat trap, then we would all be living in glass houses instead of putting storm windows on the house or switching to double pane or triple pane windows or e-glass. So that's another story that needs to be thought about seriously. And finally, if you've ever taken a course in 7th grade life science, the first question you want to know is, what is so unclean about plant food? And really, we're talking about this equation right here that shows CO2 plus water in the presence of light and a catalyst yields C6H12O6, glucose, plus it gives off oxygen. That's what photosynthesis is doing. And at the same time, what you're doing right now is this equation in reverse. You're breathing in oxygen, you're metabolizing sugar, glucose, and you're producing in your breath water vapor and CO2. So this whole process of dumbing down the science with deceptive analogies is really stupefying. So we get back to the diagram that the climate activists type like to use. And basically, this is showing temperature in a very exaggerated scale. It goes from 0 to 1 degree Celsius, and it's called temperature anomalies. And to use a scale like this for data like this implies that there is some basis for saying that small changes in mean Earth surface temperature is significant. I haven't seen any data yet that says it is significant. It's just shown here. And then using this curve of CO2 laid alongside it or over it shows that, okay, you got a correlation. Not a terribly good one, but you got a correlation. And I've had enough courses in statistics and probability and game theory to know that correlation is no proof of cause and effect. It only gives you a clue. You got to go do your homework and find the real cause and effect. And if you look at this curve, it doesn't really match what you would expect from looking at the CO2, because from about 1800 through about 1930, the curve is essentially flat. There is a temperature pause. Yeah, there's a little scatter in the data, but it's essentially a flat curve. You get a spike up through World War II, and then you get another temperature pause from about 1950 through about 1970. And then this temperature goes up again. And then finally around 1998 through about 2012, you get another temperature pause. And we'll talk about that one specifically a little later. So the smooth curve that shows the CO2 increasing doesn't really match the data. So the next question you have to ask is, where did you stick the thermometer to measure this data? And in reality, you find out that you're talking about atmospheric temperature. And 70% of the Earth is covered in water. There's no thermometers there. Also, the inhabited land is only about 10% of the Earth's surface. So you don't have a lot of temperature data there. So you're calling this an average surface temperature or a mean surface temperature. But where do you get the database to make these calculations accurately enough that you can show very small differences of fractions of a degree C and say they're significant? The next question you have to ask is, how do you get a valid computer representation of the data? And the question comes down to one of, are you doing real predictions of what the data will be based on some scientific principles, or are you just curve fitting? And there's a significant difference between the two. The other thing to think about is, what is the real global warming effect of our atmosphere? If you go to Wikipedia and look up black body radiation and scroll down, you come across planetary equilibrium temperature. And you find out they've done a calculation of the energy balance between the sun and the earth, all based on electromagnetic radiation, light of a lot of different colors. And without an atmosphere, the earth would have a temperature of 18 degrees C or 0 degrees Fahrenheit. And yet we're looking at temperatures up in the 15 degrees, 60 degree Fahrenheit range. And oh, by the way, this little wiggly line up in here, that's this line rescaled to match the big picture. And when you look at it on the basis of the big picture, it really doesn't look that spectacular or that scary. So we're looking at a situation where the real atmospheric global warming is around 60 degrees Fahrenheit, 33 degrees centigrade. And if carbon dioxide was that much of a contributor, with an increase from 280 parts per million to 415 parts per million, that's a 48% increase. You'd expect more than a single 1 degree C increase in temperature. Now, the whole issue of climate change gets to be very fuzzy. And one of the definitions I found from a climate activist site is a long-term shift in the weather patterns that can be referred to one place or the planet as a whole. So from some data that I came up with, is the rest of it? Here it is. This is really what we're talking about in terms of weather and climate change. Weather is what we normally expect over hours, days, maybe weeks. And a couple examples of that would be a common cloudburst that lasts for an hour or so, or a snowburst that lasts for an hour or so. Then on a daily schedule, you look at something like a nor'easter, it'll last a day or two. Hurricanes, depending on how you count them, whether you track them from when they come off the coast of Africa as a tropical depression and slowly grow into a hurricane migrating across the ocean, they last from someplace to days to weeks. We also get wet seasons and dry seasons that last from weeks to maybe into months. And you get into these funny situations where you have the year without a summer. In 1815, a volcano by the name of Mount Tabora exploded and threw enough junk into the atmosphere that the summer of 1816 didn't really happen. Crops were destroyed, didn't grow, and they had snow in July. Then you get to things that are on the yearly scale, El Nino, La Nina. And the polar vortex keeps coming back year after year. And the Dark Ages started with another volcanic eruption, probably in Greenland or Iceland, that literally turned the sky dark in 530 AD. And when you start to talk about La Nina and El Nino, you're talking about a situation in the Pacific where you oscillate back and forth between a warm section, which is El Nino, that brings the sardines to the coast of Chile, and the fishermen go out about Christmas time and catch them. And that's the El Nino part of it. La Nina is just the opposite. It's a period when you get cold water on the Pacific Ocean and fishing is not so good. Then you get things that happen on the order of decades, PDO, which is the Pacific Decadal Oscillation. There's also an Atlantic Decadal Oscillation. And hurricane cycles are on decades long. Hurricane cycle is 20 years. In fact, there was a period of time from around 2005 to 2015 when no major storm hit the coast of the United States. Then we get to the Little Ice Age, and that was decades long. And the interesting thing about the Little Ice Age, it wasn't just one cold period. It was 3 separate cold periods separated by a warm spell. So there we have an example of the Earth in several locations getting very cold and then getting warm again, all without burning fossil fuels. Then the century-long things are things like the Younger Dryas. Dryas is the name, part of the name of a flower called the Dryas octopedia that grows in the tundra, and its pollen shows up in ice cores. And if we look at this curve in here, you can see that coming out of the last glaciation period, we're looking at a drop in temperature, and all of a sudden we hit bottom. It's down about 5 degrees C, or about 8 degrees Fahrenheit, and then starts warming, and you get this little dip right here. And that's about the time of the Younger Dryas, when for some reason or other, the Gulf Stream stopped, and it stopped carrying warm water and warm weather to Europe, and the glaciers came back for about 12 to 1,500 years. And then you get the greening of the Sahara, and periodically the spin axis of the Earth wobbles. And when it wobbles in the right direction, the monsoons hit the Sahara. And when the Sahara gets wet, it blooms green. When the monsoons shift, because the wobble went the other way, it dries up again. This has happened over and over again. So this is a significant climate change that has nothing to do with carbon dioxide. And finally, we get the medieval warming. This is a period of time that started around 800 AD, where the range of growing wheat moved 100 miles north, which meant that Tunisia was no longer Rome's breadbasket. So there are events happening, and there is independent assessments of what the hell was going on at that time, like the change where you can grow wheat. And also we get into the issue of growing glaciers. And we go back to this particular chart. In order to grow a glacier, you have to have the summers cold enough that the snow doesn't melt from the wintertime. And this has to be a continuous process for several years. The glacier that used to sit over New England, the Laurentine ice sheet, grew out of Canada over the course of years. And as a result, it grew as far south as St. Louis in the Midwest, Cape Cod, and Long Island are what they call glacial moraine, which means it's the junk pile at the end of the glacier. You think of a glacier as a combination of a bulldozer and a conveyor belt. It scrapes the earth and picks up stuff and just carries it to the end. When it melts, it just drops it there. That's a glacial moraine. Terminal glacial moraine is the full title of it. So in order to get a glacier, you have to drop the temperature below 32 degrees F or 0 C. And a 5 or 8 degrees C change, which is commonly shown in these kind of charts, isn't enough to get you cold enough to keep the snow from melting. And one of the interesting ones is during World War II, a flight of P-38s was flying over to Europe. They crash landed on the Greenland ice cap. In about 1993, they went back to get them. They found them under 300 feet of ice. So in that time period from World War II, 1940s, through 1993, about 50 years, the Greenland glacier grew in that particular location 300 feet. So lots of things are happening. And I mentioned that La Nina. Well, recently they've had a number of cases where Category 4 and Category 5 cyclones have been hitting the Pacific in areas they're not used to. And where they traced it back to the fact that because La Nina cooled the Pacific, the cyclones were forming closer to the Indian Ocean where it's warmer. And the net result was they were hitting the west coast of, the east coast of, well, depending on whose side of the game you're on, the west coast of the Pacific or the east coast of the Asian continent, areas that they're not used to. And the other thing that is quite prominent is the range for growing oranges in the United States has moved 350 miles south. So the net result is the only place to grow oranges is in the southern half of the Florida Peninsula. So when you start to think about these things, these events are locally occurring and they have been caused by temperature differences much greater than the 1 degree C that we're seeing from the so-called carbon dioxide effect. And you get to the conclusion that the average Earth temperature or the median Earth temperature is a secondary effect. It's the local conditions that really control climate change. And before we get into the funding, we need to go back and take a look at the chart that, this type of chart that Frank uses. Start to look at this chart, and it has some interesting characteristics about it. One is that we've been in a ice age since about 2 million years ago. And this is an expanded view of what the last million years looked like. And you can see here, we're getting these spikes up in here. And really what this represents is about 110,000 years of glaciers, this little period down in here, followed by 15,000 years of global warming. And this cycle keeps repeating over and over again. And that's what we're in right now, where we came out of the last glaciation period about 22,000 years ago, started warming up, went through the Younger Dryas, warmed up, and this is what's been happening for the last 10,000 years. Not a lot of differences going on. And if you look at the characteristics of these previous warm periods, the temperatures there, they're a little higher than where we are now. Maybe we're going to get there soon, as the climate activists predict. And one other thing that's worth interesting looking at, this is what's been going on in the Earth for the last 100 million years, 1,000 million years, actually, billion years. And you can see that it doesn't look anything like the Earth that we're used to seeing on a map right now. And that this 500 million years ago, that's the beginning of this chart. And you see an awful lot of variation in temperature that was probably caused by the fact that the bits and pieces of the continents were moving all over the place. And about 100 million years ago, this thing got really interesting when South America pulled away from the coast of Africa. So there's a lot of other stuff going on besides changes in the level of carbon dioxide that probably have a very significant impact on climate change. Now, the other interesting thing that keeps coming up is they're talking about ocean rising and flooding everything. And yet, when you look at the data from the end of the last glaciation period, last glacial maximum, the oceans have risen quite a bit. They're down 140 meters, which is more like 500 feet. But the interesting thing is, after most of the ice melted, there's very little changes happening over the last 6,000 years. Things are stabilized quite significantly. So expecting a sudden dramatic change is a little bit pessimistic. I don't think it's real. You start to look at some of the other predictions. And Al Gore put out a movie called An Inconvenient Truth. The problem is none of his predictions have ever happened. There's 35 errors in that movie. 9 of the errors were so egregious that you can't show the movie to kids unless you explain them. And the other interesting one is they just took down the sign of Glacier National Park saying the glaciers will be gone by 2020. They're still there. And there's several other issues that keep coming up that really don't fit well. And this quote down here, I particularly like. The climate alarmists can't get a break. NASA is reporting that sun is entering one of its deepest solar minima of the space age, and the Earth atmosphere is responding in kind. We see a cooling trend, says Martin Nalonska of NASA's Langley Research Center. High above the Earth's surface, near the edge of space, our atmosphere is cooling and losing heat energy. The current trend continues. We could see a space age record cold. This is the kind of thing that brought on the ice age. It was called the Maunder minimum. So I come to the conclusion that if you search the internet, you find too many conflicting opinions, too much conflicting data, and too much panic porn. Too many times the solutions precede the problems. So rather than making a tinfoil hat and dealing in conspiracy, I fall back on my technical training and experience. CAGW, concocted Al Gore warming, is nothing to bet the farm on. So, ladies and gentlemen, thanks for watching. And as I mentioned on several of these shows, if you have a different opinion or you have an opinion you'd like to express on the show, give me a call, send me an email. My email is simple, it's just my last name, BINNS@comcast.net. And it shows up again at the credits at the end of the show. Or you can contact me through BevCam. So thanks again for watching, and stay tuned. There's more to come.